instructions. If you're not going to follow along today, you can just sit, relax and wait. But yeah, we will start very shortly. All right, looks like we're ready to go. For anyone who only just logged in, my name's Heidi. I'm from the Onkaparinga Library and I want to give you all a big welcome to Science Week 2020. How exciting. Hopefully at home or in your classroom you've already been doing some science stuff this week. But if you haven't and this is the first one, what a great one to start with. So in case you didn't know, Science Week 2020, our theme is celebrating marine environments. So we are going to do something to do with marine environments, which is oceans. Today we all get to be scientists. Before I worked here at the library, I was what was called a dietitian, which is a food scientist. But today we're all going to be marine scientists. So marine means oceans. Now, oceans are pretty important to us here in Australia, because we're surrounded by oceans. So it's something that we're going to talk about a lot over our session today. Now, there is going to be some talking from me, but then also talking from you between the people in your class or at home. So anytime I need your attention and I need you to come back and listen, I'm going to do this. So when you hear that, that'll be time to come back and listen to the next part of what we're doing. I said a welcome before. We have schools from as far as Mount Gambier logging in today. So welcome to everyone who has logged in. This is great. It's very exciting. Let's get started. So in case your teacher or parent hasn't told you, today we're going to do 2 experiments. One is about saltwater and water density, and then the other one is about creating a mini ocean and seeing what happens when there's water pollution. So for today's session, I have 4 keywords for you to listen out for and to think about. Now, the first one is ocean pollution. We're going to talk about that one in the second experiment. The next one is density, which is what we're going to talk about very shortly. The third one's a bit of a gimme because I'm pretty sure you all know about it, but it's ocean. You'll hear the word ocean a lot today. And then the fourth one is filter. It's a word that you may not have heard of, or it's a word that you might have heard of but don't know what that means. So we're going to do that. So, like I said, today we are going to do water density and floating experiment. Then we're making our mini polluted ocean. Then we've made a special animation for you that's about the plastic life cycle, so we hope you like that. Then we're going to have a little bit of a chat about what you can do to help protect our oceans. And then at the end, to make sure you've been listening, we're doing a quiz. So listen along the way because then you'll have a better chance of getting the answers right at the end. So let's go. First experiment we are going to do is our water density experiment. So we are going to be using some water. I'm using these nice big vases, but you will have jars there with you at home. And we've got some food colouring, we've got our spoon, and we've got some salt. So first thing we're going to do is we are going to put some food colouring into our waters. So you will have your water probably in a cup. And so the first thing I'm going to do is add some blue food colouring to this jug. Now, I've got a lot more water than you'll have, so I'm adding a lot more colour. You'll probably only need 1 or 2 drops just to make the water a different colour. So I'm going to stir this in, make this one nice and blue. Now, our blue water today is our fresh water. So fresh water is just water out of a tap. Now, on this side, we're going to add some red food colouring. And so today, our red water is going to be our salty water. So I'm going to stir that in, make it nice and red. So we have some fresh water, which is blue, and it's going to be salty water, which is red. So if you have your salt there, grab your salt and we're going to pour it into the red water in your cup. You should have this in a cup, and then use your spoon to stir it around. Now, while we're stirring, we're wanting this salt to dissolve, and it takes a little bit of time. So I'm going to talk to you about density while we stir this salty water. So the technical definition of density is the number of parts in a liquid of the same volume. So that's a little bit tricky, so let's break it down. So we're talking about number of parts. So if we think about our two jugs, we have the same volume, which means the same amount. In this side, this jug just has parts of water because we haven't added anything to it, or parts of water and a little bit of food coloring, but mainly parts of water. Whereas on this side, because we're adding salt to it, this one has parts of water and parts of salt. So they're going to dissolve in. So this jug on the right-hand side, the red one, this one has more parts in it. So it is more dense. So the more parts that are in a liquid, the more dense it is. Now we're going to talk about what that means in a minute, but basically the density of a liquid, so how dense this liquid is, will change whether it floats or whether it sinks. So we're going to do some experiments in a second, which will hopefully show you the different density between these two. Now, when we're doing experiments and when we're scientists, what we need to do is we need to make predictions. Now, predictions are questions that we ask about based on some things that we know. Now, we know that the two liquids we have different densities, so we're going to make some predictions about what might happen when we put them in these jugs, in these vases next to us. It's okay to get your predictions wrong, because being a scientist is about making mistakes and learning from those mistakes and then changing it next time. So we're going to cross our fingers that our experiments work today. But if they don't, that's okay. And if we predict something and we don't get it right, that's all right as well, because it's all part of learning. So my salt's starting to get pretty dissolved. I've got a little bit still in the bottom, but that's okay. I pre-dissolved some salt in this water, so I'm pretty happy that it's really salty. So first thing we are going to do, so grab your jars if you're following along. If not, you can just watch. First thing I'm going to do is I'm going to put some blue water in this one. So remember, this is our fresh water. And then I'm putting some red salty water in the other. Okay, now the trick here, we have our fresh water, which is less dense, and our salty water, which is more dense. The first experiment we're going to do is we're going to pour some red salty water on top of the blue water. Now I want you to have a think, speak to the person next to you and predict what you think will happen. Do you think the more dense water will sink or will it float? So I'll give you 30 seconds to talk to the person next to you. Okay, are we ready? We're going to pour this in. Now we don't want to just plonk it straight in. We're going to pour it down the side and we're going to see what happens. Okay, what do we have? We have some purple water. What has happened here is because our more dense water sinks, it has gone through the blue water all the way down to the bottom and it's mixed it all together. And because we've done blue and red, it's mixed together to be purple. So now we're going to do the opposite. We've got our red water here, which we know is more dense and we know sinks, and we are going to put some blue water on top. Again, I want you to have a think and make a prediction. What do you think is going to happen? Do you think the blue water is going to float, or do you think the blue water is going to sink? So turn to the person next to you and you have a think about what you think might happen next. All right, let's see. So what we're looking for is whether this blue water is going to sink or whether it's going to float. Let's have a look. pouring it very carefully. Okay, now, can you see, compared to our purple one, that on this one we've got some clear red water at the bottom, which is our salty water, and then we've got a bit of a purpley colour at the top. So you, depending on how much salt you have in your water and how much colour, you might have a nice really clear blue line of water on the top. But ours is a little bit mixed, but it still shows you the difference between this one and that one. Now, the reason this has happened is because our red water, which is more dense, has stayed at the bottom, and our blue water has floated on the top. So it hasn't mixed all the way through and gone all the way down. So what we can see is we've got two little differences here in the colour. So let's talk about what that means. What that means is salty water, like the ocean, is more dense than fresh water out of the tap because it has more parts in it. So the more dense something is, the more it will sink. Cool? Excellent. So we're going to move on to the next experiment. Now, what you'll need to do is empty out your jars and get some fresh water for the next experiment. Now, I've got a little helper who's going to come in and she's going to do that for me. So we can empty those ones while I go through what you'll need. So you'll need your jars back for the next experiment. And hopefully you have one of these, which is our little turtle friend. We are going to have some different types of plastics. So I have some soft plastics here, and I have some hard plastics. And we're going to see what they do in the water. And then we also have a piece of material. Mine's a nice shiny one, and a rubber band. Now this is going to be our filter. Now remember I said that was one of our key words for today. So when we get, can I grab one of the vases? Empty. Empty, thank you. Oh, and I've got some sticky tape too. So to start, thank you, we're going to use, you'll have your jars, and we're going to stick this to the back. So I'm going to get some sticky tape. And stick it around the back so we can see in, and we've got our little turtle friend. Now, do turtles live in the air or do they live in the water? I can't hear you, but I'm hoping you said in the water. Turtles live in the water, so our turtle needs some water. Now, if we hadn't added that red food colouring, you could use some salty water if you want to make it more realistic, because turtles do live in salty water. So add your water into your jar, and what we're going to do is we're going to see about what the plastics are going to do to this turtle's environment. So this is where he lives. Now, first thing, have a look at that water. It's nice and clear. The turtle can swim around if it wants to. Nothing's stopping it from living its best life in this little jar. But what we're about to do might change that. Now, I want you to grab your soft plastic. So I have some bubble wrap. You might have seen that. I had lots of fun with that. I have a balloon. We all know those from parties. And I've also got a sneaky chocolate wrapper. I ate a block of chocolate and I peeled some of that wrapper off. Now, we're going to put them into this water. And I want you to predict with each one whether you think it's going to float or whether you think it's going to sink. So the first one we'll put in is our bubble wrap. Now I'm going to use the spoon to just dump it down. And that one has floated straight to the top. So that's definitely a float. Let's try the balloon. Now I want you to have a think, have a predict in your head, is this going to sink or is it going to float? All right, let's put it in, let's see. Let's give it a dunk. That soft plastic has floated as well. Who would have thought? All right, final soft plastic. We're going to put the chocolate wrapper in. Have a predict. Do you think that it will sink or do you think that it will float? Let's see. Put it on the side. What's happening with this one? Oh, it's a bit of both. It's a little bit of floating and it's a little bit of sinking. It's not all the way to the bottom, but it isn't at the top like the others. So you can see that different soft plastics have different levels of floating. Now we're going to move on to our hard plastics. I have some straws, drinking straws. I've chopped them into smaller pieces so they're easier to work with for us. I have a peg. You might have these plastic pegs from your washing line. And I also have a plastic lid. Now this one's from the end of a tube, but the same thing you might find with your milk bottle lids or lids from other jars or those sorts of things if they're plastic. So let's see what they are going to do. First things first, peg. Predict, do we think it's going to sink or do we think it's going to float? Let's have a think. I think this one might sink. Let's have a look. Can you see that? Right to the bottom. All right, next one is our drinking straws. Sink or float? Have you made your prediction? Ready? Now you could be following along with your soft and hard plastics in the classroom or at home if you're doing this along with us. These ones, I don't know if you can see that, they have kind of sunk and still floating a little bit. What do we think about this water? Is it looking nice? Don't know. All right, last thing is my lid. Sink or float? If you've got a different plastic with you, you could predict based on that one. Putting it in. Just chuck it down the side. That one's kind of floaty. Okay. Now, what I want us to do next is I want us to think about how our little turtle friend is feeling now. Do you think he's living his best life in there? I think he might be a bit cluttered. What do you think? So this is what happens in our oceans when we don't recycle our plastics. They go into the ocean and what happens is it makes it hard for our ocean creatures to live. Sometimes they get caught in them, especially things like bubble wrap. Sometimes they accidentally eat them, like the drinking straws. And sometimes they just ruin their environments that they live in. So what can we do about that? What we're going to do today is we're going to filter the water. So you'll have your other jar and we have our piece of material and a rubber band. So I'm going to put that over and I'm going to stretch the rubber band around. I'm just going to put a little bit of a cup in there to catch my plastics. Now when we do this, we need to pour it really slowly because it takes a little while for the water to get through that material and we don't want it to go everywhere all over our tables. So we're going to do this slowly and I want you to see what happens to the plastics and what happens to the water. You might have a guess now, a prediction about what might happen with that. Let's see if I can wiggle out some of the plastics. Oh, there we go. So, if you predicted that the filter, which is our piece of material, would stop the plastics from going into the water, then you were right. So, filters are something that they use in the ocean at the moment to try and catch all the plastics. So, if there are plastics in the ocean, they can use filters to stop that from happening. So, what we can do is we can pull this off, take all of our plastics away, and then give our turtle back his nice clean water. So now he can go on living his best life again. Now, when you take these home or in the classroom, you could add some ocean things that are good for a turtle. So you could add things like sand, you could add things like seaweed. Seaweed's helpful for ocean creatures, or you could add things that you normally find in the ocean like shells and that sort of thing. So when you take that home, you can put the lid on and you can add some more stuff, or you can just leave it like that. Now, one of the things that is really important for us in Australia and being marine scientists today is that we protect our oceans. So when we had the plastic in our water, that is called ocean pollution. So pollution is a word that covers any type of rubbish. So if you see litter in your schoolyard or at home, that's called pollution. So when it's in the ocean and it's in the water or on the beaches, it's ocean pollution. So we're going to watch an animation now about the life cycle of plastics. Now, we're hoping our technology will work, so bear with us, but we're going to try and share it on your screen so that you can see our animation.
Week. I'm going to tell you a story today. It's about you and some plastic. It's called A Plastic Story. Let's pretend that you've gone to the wooden playground at Port Noarlunga for a picnic and a play. This morning you were in a bit of a rush, and so instead of looking for your backpack, you thought, I'll just put my picnic into a plastic bag. You got into the car, and halfway to the playground you realised you'd forgotten your drink bottle. Oh dear. Mum had to stop and buy you a bottle of water in a plastic bottle. Now, you've been running around at the park for a while now, and you're getting a bit hungry and very thirsty. You drink your water and you eat your picnic. But what do you do with your rubbish? You can't wait to get back to playing, so you can't be bothered going back to the car to stash your plastic bottle and your plastic bag for recycling later, so you just chuck them in the bin. There's nothing wrong with that, right? You think? At least I'm not littering. I'm putting my rubbish into the bin. No sea creatures will get harmed from this, right? Well, unfortunately, you may be wrong there. If everyone had that same attitude, what we might end up with is a lot of plastics that don't get recycled, and it will fill up all of the bins really quickly. But what happens with that plastic that you put in the bin, you might ask? Well, I'm here to tell you. Each week, the rubbish truck comes to the playground, and to your house too, by the way, to pick up that rubbish. It takes your bottle and plastic bag in the back of the truck to the rubbish dump. We also call that landfill. Sometimes what can happen is that heavy winds and weather come along and blow some of that rubbish away. Your plastic bag and plastic bottle in this story actually ended up in the Onkaparinga River. They got picked up by the current of the river and pulled all the way to the river mouth at Southport, then ended up in the ocean. Eek. So this is where the trouble starts. As the plastic gets moved around in the ocean from the tides and the currents, the plastic breaks down into smaller pieces. Sea creatures minding their own business in their own ocean homes accidentally eat those bits of plastic. Sometimes they also get stuck in them. The problem with not recycling your plastics is that now scientists all over the world are finding more plastic inside of sea creatures than ever before. There is so much plastic in our oceans at the moment that the currents across the world pull this rubbish into patches where the plastic gets stuck. These are called ocean rubbish patches, and more sea creatures get caught or get sick from eating this rubbish. Yuck, right? The biggest patch of rubbish is called the Great Pacific Rubbish Patch. And do you know the worst thing? It sits right near Australia. So, enough of the doom and gloom. Ocean plastics are the problem, but what is the answer? Recycle those plastics. It's the easiest way that you can make a difference and reduce the amount of plastic that ends up in our oceans. But that's just one thing. Now I want to put a question to you. What else could you do?
Hello, back again. Did you see my sneaky Bitmoji person in there? I hope it looked like me. So in the animation and now, we're going to think about what we can do. We have talked about filtering and we've talked about recycling, but there are some other ways that you can stop ocean plastics from getting to the ocean or also taking them away. So I want you to talk to the person next to you or talk to the people in your group at your tables and have a think about a few things that you could do that could stop ocean plastics from harming our sea creatures. So I'll give you 2 minutes and then I'll ring the bell and we'll come back and we'll do our final quiz. Okay. Hopefully you came up with a few really good ideas. Now, if you have any questions or if you want to make some comments, you can get your teacher or parent to put a question or comment in the Q&A box. Also, you might work on your ideas for reducing plastic pollution further in the classroom or at home. And feel free to let us know what you've come up with. If you want to do anything and bring it into the library, we are here to listen and would love to hear from you. While we're waiting for any questions, we're going to do our quiz. So, are you ready? Basically, what we're going to do is I'm going to ask a question. You're going to think of the answer in your head, and then I'm going to tell you the answer. And so you can either go, yeah, or, I didn't think of that. All right, so question 1. What is more dense? Water from the tap, which was our blue water, or salt water, which was our red water? All right, have a think. If you guessed that salt water is more dense, then you were A-okay. So remember, our salt water was the one that had more parts in it, so it was more dense. All right, question 2. Are we ready? If a liquid is more dense, will it float or will it sink? Have a think about that one. Okay, a liquid will sink if it is more dense, which was our salt water, which went through the blue water. Okay, this one's a true or false. Number 3. True or false, hard plastic always sinks. You think about what happened when we put some hard plastics in. Okay, the answer is false. Some hard plastics will sink, but some will float. So well done if you got that one right. Okay, second to last question. This one is from the animation. See how well you were listening. What are the big collections of plastic waste in the ocean called? Can you remember? They are called ocean rubbish patches. Now, bonus points if you remembered the name of the one near Australia, which is called the Great Pacific Rubbish Patch. So well done. Okay, final question. Number 5. Should you put your plastic in the rubbish bin or should you recycle it? Have a think. Okay, I am hoping that you all said recycle because that is what we want to do with our plastics. recycle. In Onkaparinga, which is the council that we're in, might be different if you're somewhere else like Mount Gambier, but hard plastics can be recycled in your yellow bin, and soft plastics you can bundle up and you can take them to the supermarket. So Woolworths and Coles have big collection points for our soft plastics. Which leads me to another thing. In your packs that you got, that your teachers may have or you picked up from the library, is a list of places where you can recycle all of the things we used today. So what we want to make sure is that we're not just chucking them in the bin, that we're collecting them and putting them in the right places. So that is the end of our session today. A few things before you go. In your packs, there are extra information, so where you can recycle all the parts, and some more information about ocean plastics and those sorts of things. If you want to check out Eventbrite, there are more Science Week things going on for the rest of the week, so you can go have a look at that. In our library, we have heaps of science books, so come in and borrow them. And we also have an ocean display, and we have some sensory bags which have some real life ocean stuff in them. And we also have some sand with some rubbish that you can practice and see where you recycle them. So that's at our hub library here, but different libraries that are closer to you might have other stuff going on. So thank you all for joining us. I hope you enjoyed it. Please feel free to contact us with feedback or say how much fun you had, or show us what you're doing about ocean plastics. That would be wonderful. So thanks. See ya.